Okay, in our last class, we discussed about synthesis of two insect pheromones, more particularly multistriatin and bambicol. Today also we will discuss two insect pheromones. So one is 3,11 dimethyl 2 nanocosane. So this is the insect pheromone. It is isolated from German cockroach. Okay, and Blatella germanica is the scientific name of this particular cockroach. This cockroach is called German cockroach. So from this, the moiety called 3,11 dimethyl 2 nanocosane is isolated. This is the structure of nanocosane, and it is more particularly the SS configuration. So the 19th carbon, this is called 19th carbon, and this one is called 27th carbon. So both the carbons are optically active, and they are S configuration, SS configuration, and a total number of carbon atoms present in this is 29 carbon atoms, and this will be the melting point. So that means this is a low melting compound. So let's look into the synthesis again. Here also we are discussing common method of synthesis of nanocosane, and also we discussing about stereo selective. Stereo selective means how we can get a SS configuration of a nanocosane. So now let's look into the method one, that is synthesis of 3,11 dimethyl 2 nanocosane. So for this, this is the compound, and the name of this compound is called ethyl acetoacetate. Ethyl acetoacetate. It's an active methylene compound. So this carbon is active methylene carbon, and this proton is active methylene proton. So what will happen in presence of base? The proton can be captured and form an anion. That anion can attack this carbon, and Br will go out. So that is how a compound is obtained. The obtained compound, so in presence of HBr, so what will happen? The ester part is there. No, ester is hydrolyzed to acid. So when ester is hydrolyzed to acid, ethanol will go out as a byproduct. Once the acid is obtained, that on heating, so acid on heating, decarboxylation takes place. That is the reason a compound obtained like this. So this particular compound is treated with a long chain halide. Okay, this is an halide. So this reaction is called a Wittig reaction. What will happen? There will be a carbon-carbon double bond between this carbon and this carbon. There is a product formation. Again, it was subjected to condensation reaction. This, of course, it's not a condensation. Of course, it's a condensation, but we can also say about nucleophilic substitution reaction. So this is the base, and this captures this proton, forms an anion. So that anion attack this carbon, and Br will go out. So that is how a product is obtained. Again, this product on treatment with the KOH. So what KOH it will do? It's a base. And what it will do, you know that this is an ester. Ester is hydrolyzed, and ethanol will be the byproduct. And obtained acid on heating undergoes decarboxylation. Carbon dioxide is going. That means this complete group will go out, convert this into a proton. Okay, then what will happen? This will be the product. And again, the second step is treatment with hydrogenation in presence of catalation. So reduction of this double bond, okay, gives rise to configuration, more particularly S configuration. Of course, here there is a possibility of getting a mixture, but uh, I'm ready. Of course, after the mixture, one can go for a resolution. So resolution means separation of particular isomer, and after the resolution, it is possible to get S and S configuration. This is about the first method of preparation of nanocosane. So that means a active methylene compound is first taken. It was treated with the halide, alkyl halide. So the obtained product undergoes hydrolysis and decarboxylation. So obtained one is treated with an halide to get a compound, alkene halide compound. So this was again subjected into nucleophilic substitution reaction. Again, the obtained one is subjected to hydrolysis as well as decarboxylation. So giving rise to mm, intermediate. This is the one intermediate, and the obtained intermediate subjected to catalytic hydrogenation. So on catalytic hydrogenation, ends up with a mixture of mixture, enantiomeric mixture, racemic mixture. That racemic mixture on resolution gives S and S configuration of nanocosane. This is about the first method of preparation of nanocosane. So I will go to the second method. So here the starting material is a lactone, more particularly seven-membered lactone. This seven-membered lactone, let's give an entry. A seven-membered lactone, when it is treated with HBr, so what will happen? So there will be a breakage here. So that means the lone pair present on this oxygen can capture a proton. Br can attack this carbon. So that is how this product is obtained. Acid is obtained. That acid, when it is treated with proton in presence of ethanol, converts into a ester. So you know that this is a halo ester. Halogen is there. Halo ester. This halo ester, when it is treated with what is called as uh, active methylene compound, ethyl acetoacetate. So there will be a anion formation on the methylene carbon. This anion attack this bromo compound. Bromo is going out, and afterwards on heating, this acid is converted into this ester is converted into acid, and acid is converted into undergoes decarboxylation and giving rise to ketone compound. Keto acid is obtained. This keto acid, when it is treated with diazomethane, you know that diazomethane is act as a source of CH2 group, methylene group. So what will happen? This carboxylic acid is converted into ester. But here I am written as a ethyl, but you have to change it as a methyl group. Okay, that changes you need to make. So from acid to ester, it is possible with diazomethane, more particularly methyl ester, not the ethyl ester. And the obtained keto ester, so it was treated with the 18 carbon atom ylide. So this reaction is Wittig reaction. So what will happen? there will be a carbon-carbon double bond between this carbon and this carbon. So that is how a alkene ester is obtained. Here, alkene ester. So when it is treated with the lithium aluminum hydride, so what it will do, lithium aluminum hydride, it will convert this ester into alcohol. The obtained alcohol, when it is treated with HBr, alcohol is converted into Br. Br means bromo compound. So again, this moiety is subjected to nucleophilic substitution reaction. Nucleophilic substitution reaction means a active methylene compound is taken. So the base, potassium tertiary butoxide, can capture this proton. There will be anion formation. That anion attack this carbon and Br will go out. So that is how a compound is obtained like this. And this compound on treatment with the KOH in presence of ethanol. So KOH means it's a base. So what will happen? This ester is converted into carboxylic acid. So obtained carboxylic acid on heating undergoes decarboxylation, converting this uh, this complete group into H. Means carboxylic acid is going out, ethanol also going out, and this will picks up a proton, and that means uh, uh, so here one thing you need to remember. This is a dicarboxylic acid. So usually a dicarboxylic acid. That means if the two carboxylic acids are attached to a same carbon, that the compounds are stay unstable, and that compounds undergo decarboxylation and converted into a monocarboxylic acid in presence of base. So that means here the two carboxylic esters are converted into dicarboxylic acid, and afterwards the dicarboxylic acid is converted into monocarboxylic acid. Okay, that's what happen when it is treated with KOH in ethanol. And this hydrogenation in presence of catalyst converts this double bond into single bond. And here one more step, that is methyl lithium. This methyl lithium treated with monocarboxylic acid attached to this carbon and converts into a ketone. So this is how the second method of preparation of nanocosane is obtained. Okay, just I will repeat. In the second method, a, a lactone is taken. So lactone on treatment with HBr, a acid, a bromo acid is obtained. So the obtained bromo acid on treating with H plus in presence of ethanol gives an ester. This ester, when it is treated with the active methylene compound, it gives a keto acid. The keto acid and treatment with the diazomethane gives an ester. Means acid is converted into methyl ester. This methyl ester and treatment with halide, this is nothing but a Wittig reaction, so gives rise to alkene ester. This alkene ester on reduction with the lithium aluminum hydride, this ester is converted into CH2OH. This CH2OH, when it is treated with HBr, a bromo compound is obtained. That is this one. This bromo compound undergoes nucleophilic substitution reaction, so giving rise to a dicarboxylic ester. So this dicarboxylic ester on treatment with what is called base. Okay. So what will happen? Because here two carboxylic esters are attached to the same carbon atom. So two carboxylic ester is converted into two carboxylic acid, and one of the carboxylic acid undergoes decarboxylation, forming a monocarboxylic acid. That monocarboxylic acid, when it is treated with hydrogenation in presence of catalyst, the double bond is converted into single bond, and the saturated carboxylic acid, when it is treated with methyl lithium, converts a carboxylic acid into ketone. So this is about the second method of preparation of what is nanocosane. So with this, I will go to the third method. The third method is called stereoselective synthesis of 3,11 dimethyl nanocosane. Why we are giving stereoselective synthesis of nanocosane means sometimes examiner will ask you more particularly give the method of stereoselective synthesis of nanocosane or grandisol or bambicol or multistriatin. So you will ask, that is the reason I am also giving stereoselective method of synthesis of insect pheromones. This stereoselective synthesis of nanocosane, it is synthesized in but just by the combination of part A and part B. So part A will have S configuration compound, and this also part B also is having S configuration compound. So what will happen? Combination of these two. So this is a nucleophilic in nature, and this will be the O tosylate will go out, and there will be a new bond formation between this carbon and this carbon. So Mg attached carbon will be nucleophilic in nature, and tosylate is a better living group. Nucleophilic substitution reaction happens, and a product is obtained here. So here an alkene is there. I think you are aware about the mercuration and demercuration. So first step is the mercuration. That means mercury will add to terminal carbon atom, and acetate will add to more substituted carbon atom. And this moiety, when it is treated with the sodium borohydride in presence of NaOH, undergoes demercuration. The mercury is added to terminal carbon now, so that is converted into hydride source. Sodium borohydride act as a source of hydride. The hydride is replaced by means mercury compound is replaced by hydride. So that is the reason here CH3 is there, and acetate group on hydrolysis converted into OH. This is about this treatment with mercuric acetate is called mercuration. Treatment with sodium borohydride is called demercuration. So this step is an example of mercuration and demercuration of organomercuric compounds. And then, so this obtained compound on treatment with the chromium trioxide. Chromium trioxide is an oxidizing agent. So what it will do, it will convert a secondary alcohol into ketone. So this is about what is called as stereoselective synthesis of nanocosane. But here I took part A and part B. In the next, I am discussing about the synthesis of part A and then synthesis of part B. So in that, the part, let's look into the part A synthesis. This is called citronellol. Citronellol is a terpenoid, okay, and it's a naturally occurring compound. This citronellol is treated with tosyl chloride. So tosyl chloride means it will convert a hydroxy group into tosylate. So let's give an entry. Okay, so tosyl chloride converts a hydroxy group into tosylate. Tosylate means OTS. OTS is called tosylate. So hydroxy is a poor living group, but when hydroxy is converted into tosylate, it will act as a better living group. So once tosylate is obtained here, so it was treated with the sodium iodide. Sodium hydride means I minus will attack this carbon, and tosylate will go out. That is how hydro compound is obtained. This hydro compound, when it is treated with uh, butyl lithium, okay. I think you are aware now, aware about this is a long chain alkynyl lithium. So what will happen? There will be a new bond formation between this carbon and this carbon. Lithium and iodide will go out. So that is how a product is obtained. So this particular product, you know that this is a triple bond and this is a double bond. So only the double bond can react with MCPBA. So that means MCPBA is an epoxidation that will convert a double bond into epoxide. So at this stage, you know that it was ring opening. Epoxide is converted into diol. So this particular diol. Right. So that means this epoxide, when it is treated with periodate. So periodate oxidation. What is the periodate oxidation? Periodate converts vicinal alcohol into aldehyd. So that means this carbon is converted into aldehyd. This carbon is converted into ketone. The ketone is a byproduct that will go out. Okay, that is how an aldehyde is obtained. So this particular compound, when it is treated with lithium aluminum hydride, so lithium aluminum hydride converts aldehyde into CH2OH. That CH2OH is treated with tosyl chloride. That means alcohol is converted into tosylate. That tosylate, when it is treated with sodium cyanide, a, tosylate is replaced with Cn minus. So that is how a Cn minus is obtained. So at this stage, so this one is subjected to a Lindblad catalyst. Lindblad catalyst means hydrogenation in presence of palladium and barium sulfate uh, 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 catalyst. So triple bond is converted into double bond, and then uh, okay, here it's not a triple bond, hydrogenation. So hydrogenation bond, and then what is there here? Cn is there, and you know that hydrogenation can also occurs to Cn. That means Cn is converted into primary amine. Obtained primary amine, so it was treated with nitrous acid. HNO2 is called nitrous acid. What it will do? It will convert a primary amine into diazonium salt. That diazonium salt picks up a proton uh, uh, and that tosylate, that means diazonium salt is converted into uh, converted into tosylate. So this is how the part A is obtained. I will repeat this particular step. Hydrogenation in presence of palladium charcoal means a triple bond is converted into double bond into single bond. This is not a Lindblad catalyst. And during this triple bond reduction, hydrogenation is also occurs to a nitrile. Nitrile is converted into amine. Again, the amine is when it is treated with nitrous acid, amine is gets converted into diazonium salt. So the diazonium salt, when it is treated with tosyl chloride, it will give you tosylate. This is about what is called as part A synthesis of nano cosine stereoselective synthesis. So with this, I will go to the synthesis of part B. So this is the citronellal. Okay, citronellal means again you know that it's a naturally occurring terpenoid. So this citronellal, when it is treated with tosyl chloride, OH is converted into tosylate, and that tosylate, when it is treated with the Cn minus, it will give you nitrile compound. So this nitrile compound, when it is treated with sodium hydroxide, you know that so on treatment of nitrile with sodium hydroxide, it converts into amide initially, and later on amide is converted into carboxylic acid. The carboxylic acid, when it is treated with diazomethane, it will convert carboxylic acid into ester. So that is how ester is obtained from the nitrile. This is about the conversion of nitrile to acid, acid to ester. So the two transformations are involved. It was and this part will go out as a acid product that will go out. Reaction. So in this named reaction, what is happening? There will be okay, right. So let's recording. Okay, let's present now. Right. Now carbobromo. It's a name reaction. So that means a carboxylic acid, when it is treated with silver oxide, undergoes decarboxylation, forming a bromo compound. So this bromo compound, when it is treated with organosilicium, it will happen here, the bromide, okay, Br. And here, one thing you need to remember, uh, uh, the living group is called cyanogen bromide. CNBr is called cyanogen bromide. So that means the bond between the selenium and nitrile uh, form a bond with this carbon. So that is how organoselenium compound. Of course, this is also organoselenium is treated with the sodium hydroxide in presence of hydrogen peroxide. So you know that this what is called role of organoselenium compounds in organic synthesis. So when this moiety is treated with hydrogen peroxide in presence present here. So that means anion is coming over here. This will go out. So that means there is a formation of double bond alkene. And this alkene ester, when it is treated with lithium aluminum hydride, so you know that lithium aluminum hydride is a reducing agent. It will convert when it is treated with lithium bromide, it will give you bromo compound. So that is how the bromo compound. Here what all is involved? Ester is converted into alcohol. Okay. Ester is converted into here from here to here. Ester is converted into alcohol. Alcohol is converted into tosylate. Tosylate is converted into bromo. Three steps are involved. So this bromo compound, when it is treated with magnesium in ether, so that means uh, conversion of alkyl halide into magnesium bromide. It's called nothing but a Grignard reagent. So this is about what is called as stereoselective synthesis of uh, what is called as nanocosane. So nanocosane stereoselective synthesis synthesized by employing the part A and part B combination. And we also discussed about the synthesis of part A synthesis, stereoselective synthesis of part A of the nanocosane, part B of the nanocosane. And with this, what I will do, I will if there are no doubt means I will take up Farenal. So Farenal, it's again one more insect pheromone, and this will be the Monomorium paranos is a uh, scientific name, and this is a cockroach. Uh, Parrow ants. Okay, this will be the diagram or image of Parrow ant, and this farinal is isolated from this uh, Parrow ant. And here, don't get confused with the farnesol and farinal. So farinal is a insect pheromone. Farnesol is a terpenoid. Okay, that difference you should aware. And this particular hands will be 2 mm. Okay, are of two kinds. One is 2 mm, another one will be 4 mm one. So 2 mm one will have a lifespan about 9 to 10 weeks, and 4 mm one will have a lifespan about 1 year. And this is the structure. And here this carbon is called the 3 carbon 3, and this carbon is called 4 carbon. And this carbon will have a S configuration. This carbon will have a R configuration. This carbon will have a S configuration. So here in this farinal, I'm only giving the one method of synthesis, that is stereoselective synthesis. And in this, part A and part B are prepared in a separate method, and part A and part B are combined to get a farinal. So now I will look into the synthesis of part A of farinal. So how this is a alkyne, so more particularly propine. So a triple bond is there. So this propine, when it is treated with ethyl magnesium bromide, ethyl, it will be in anionic nature. It will attack this carbon, and this can, yes. So this bond pair can picks up magnesium bromide. So that is how a Grignard Grignard compound is obtained. This also a Grignard. This also a Grignard. The obtained Grignard is treated with epoxide. So that means this anion is attacking here and there will be a ring opening. A alcohol is obtained. This alcohol, when it is treated with tosyl chloride, a hydroxy is converted into tosylate. That tosylate, when it is treated with lithium bromide, a bromo compound is obtained. The obtained bromo compound, when it is treated with lithium ethyne, so there will be a new bond formation between this carbon and this carbon. Lithium bromide will be the living group. And at this stage, I think you are aware about carboalumination. Methyl aluminum is a carboaluminating reagent. How it will add? A methyl group will add to this carbon and aluminum will add to this carbon. And then aluminum is replaced with iodine. So that is how A. And let's look into the how the part B is synthesized. So you know that if there is a double bond phthalic anhydride, okay, tetrahydro phthalic anhydride. Tetrahydrophthalic anhydride, when it is treated with the lithium aluminum hydride, it's a reducing agent. So it will act as a source of H minus, means hydride. Hydride can go over here and there will be a breakage here. Okay, similarly, hydride can give over here and there will be a breakage. So that is how a diol is obtained. The obtained diol, when it is treated with the tosyl chloride, it will convert hydroxy group into tosylate. This hydroxy is converted into tosylate. DMAP is a solvent. Dimethyl, it's a solvent. Okay, and that is how tosylate is obtained. Again, the obtained tosylate means yes, this OTS is called tosylate. So this tosylate, when it is treated with the lithium aluminum hydride, it will act as a source of hydride. H minus will add to this carbon and tosylate will go out. So that means a compound is obtained like this. So this particular compound, when it is treated with MCPBA, you know that MCPBA is a paracid. What it will do, it will convert a double bond into epoxide. So this, if once the epoxide is formed here, you know that what is the name of this compound? This compound is N-butyl lithium. So N-butyl lithium is a reagent. It will act as a strong base and it will capture this proton. Once N-butyl lithium captures this proton, this bond pair is going over here and this bond pair picks up a proton when it is acidified. So that is how enol is obtained, means a double bond alkenol is obtained. The obtained alkenol, here hydroxy protection. Hydroxy group is protected by using DNBCl. So it's a protecting group. O means OH protecting group. DNB chloride. So chloride is going out. DNB is attached to oxygen. So from here to here, hydroxy protection. So then from here to here, so first step is the oxidation, not the oxidation. Of course, it's an oxidation only, but here oxidizing agent is ozone. So you know that when ozone is treated with double bond, initially it will form a triozonide and then ozonide and then breakage here. So once there is a breakage here is obtained, a aldehyde CHO is here, CHO here is obtained. The obtained CHO, when it is treated with sodium borohydride, so what it will do? It will convert CHO into alcohol, OH like this, OH like this. And the KOH is the deprotecting agent. it will deprotect this DNB and giving rise to free alcohol. Now this is one alcohol, this is another alcohol, this is a trihydroxy alcohol is obtained. So here I have mentioned what is DMAP. DMAP means 4-methyl amino pyridine. What is DNB? 2,5 dimethyl benzoyl chloride. Okay, and this moiety, when it is treated with acetone, this acetone, it will protect this vicinal diol. So vicinal diol is converted into ketol. So that means acetone will act as a protecting group of vicinal diol. So that is how a compound is obtained. Now this free hydroxy group is there. This free hydroxy group, when it is treated with iodine in triphenyl phosphine, this OH is converted into iodo. So this is the part B. Now you know that part A. So part A is this moiety and the part B is this. So let's combine part A and part B to get Farenal. So this one is part A, this one is part B. So here iodo is there, this also iodo is there. So in presence of butyl lithium, one of the iodo group is converted into uh, uh, lithium here. So that means in place of iodine, lithium will be coming over, and that means in lithium is coming means this carbon attains a what is called as nucleophilic in nature. Once this carbon attains a nucleophilic nature, it can attack a electrophilic carbon and Br will go out. So that is how a new carbon-carbon bond is formed. So once a new carbon-carbon bond is formed, so here PPTS. So this is one reagent. Okay, I will tell you what is the PPTS in a later stage. So what it will do? Uh, okay, so it only cleaves this particular ketol. So ketol is converted into free hydroxy group. Here acetone will be the leaving group. And you know that this is a diol, okay, or vicinal diol. So when it is treated with peroidic acid, uh, so peroidic acid means what will there will be a breakage here, and this carbon is converted into CHO. And you know that name of this compound itself is called a Farenol. So this is about the synthesis of Farenol and synthesis of what is called as Nanocosane. This is about what we discussed about totally 7 insect pheromones. And maybe what you can do, if you have any doubts with respect to the insect pheromone, you can ask me, I will explain. If there are no doubts, maybe you can log out.